Hello, thanks for joining us today. My name is Sandra Wick. I'm the crop production agent with the Post Rock Extension District with K-State Research and Extension. Today we have a special guest with us, Dr. Ignacio Ciampitti, our K-State Research and Extension Cropping System Specialist. So, Ignacio, why don't you tell us a little bit about what your role is with that position?
Well, my role on this position is I'm specifically focused on crop production, which basically implies, looking at the different management practices, like density, fertility, row spacing. In soybeans, for example, we touch base on nitrogen fixation, crop rotation, tillage. So these are all kind of a big practices. When farmers are taking decisions about what variety, what row spacing, so we are focusing really on a big picture of the farming systems. And then our, interest and focus crops are corn, soybeans, sorghum, and also we have a little bit of canola. So right now at this point we are discussing about the soybeans.
Okay. Well, as you know, K-State Research and Extension does lots of production schools starting now. We're right in the middle of our soybean production schools, and then we'll have our sorghum and our corn. So why don't you share with us just a little bit, maybe one research project that you're doing with soybeans?
Yeah, for example, one of the things that I was discussing during the soybean schools today was about a project that we conducted on looking at seeding rates. So one of the things is, as many of you know, on corn, we discussed many situations that for increasing yields, we are adjusting and increasing population. And in poor yield environments, we tend to decrease plant density in corn. On soybeans, most of the times, seeding rate and plant density was a topic that we never really discussed much. Soybeans as a plant has a different physiology. So in terms of morphology, we see that the plant can branch and produce. The production of those branches give the plant an opportunity to compensate. Corn, as you see, we have only 1 year, so or we manage the number of plants to capture light by adding more plants, or there is no other possibilities. There is no possibility for the plant to increase or produce more leaves. Once it reach flowering, right? In soybeans, after, even in situations when we are in reproductive stages, soybean has a chance of getting a new branch and increasing, basically compensate for, the available resource and space. But this study, what we conducted in many farmer fields, we just keeps very simple. We wanted to understand basically if the theory that we use for corn, it works in opposite way, which basically means that we were looking and we have observations from research studies showing that when yields were really low, we needed a little bit more plants. And then we wanted to really capture that information from farmer fields. So we did very simple seeding rate studies in many multiple farmer fields. We tried to capture fields that they were having situations of really good yield environments, nice areas of the field versus low areas of the field. And then the weather was not a factor because we were in the same maybe 80 or 100 acre field. And then we basically, when we start synthesizing, aggregating all the data, we basically found that yes, when you're looking at 40, 50 or 60 or 70 bushel soybeans in those environments, having 100,000 plants was the optimum. In some situations even lower, maybe sometimes with 90,000 we were okay. But for environments that were with problems of pH or problems with compaction, any situation that was limiting the plants to grow fast as in the best environment, then we were seeing that adding more plants, like increasing the optimum from 100,000 to 120,000, was something that basically will help those plants to increase competition and capturing more light quickly and closing the canopy. Because our challenges on those environments was really how to close the canopy when the plants were growing too slow. So that was one of the, I think that it's an excellent insight for many farmers that are thinking about, I'm already working on using variable rate seeding for corn, and then will this technology pay or not on soybeans? Doesn't make any effect. And now they are seeing that they might have a possibility that even within one farm field, like 100 acres, you might have the chance of maybe singulate or maybe put variable rate in one section of, trying to get in the best area of the fields, 100,000 plants, and if you have poor environments, trying to increase seeding rate with the goal of making sure that those plants can compete and trying to capture light and increase yields.
Okay, so it sounds like the producer needs to evaluate their fields, look on the yield environments,
exactly,
and then adjust the seeding rates accordingly.
Yeah, and we always discuss with farmers that this is not something that they need to do only just in separate fields. It's something that they can start looking at profits even within the field and we work with multiple farmers, and even on 60 acres or small farmer fields, you have enough variability to separate one section of the field that might be yielding 60, 70 bushels versus a section of the field that might be yielding 30 bushels.
Okay.
And it might be because of a compaction problem in one section of the field. And then those are opportunities for farmers to capture more profits, to become better and more precise in managing those environments, to make sure that they can, for one point, they are not increasing the seeding rate and not basically, increasing the cost and saving cost on the situation that they are on the high yields, because with 100,000 plants was enough. And in the other situation is to make sure that they might capture a few bushels more by just adding a few more seeds on those environments that are really poor, that the plants tend to grow really small.
Research and Extension has many publications for producers out there for their knowledge. One of them, and I know that you are an author of this one, is the Kansas Soybean Management 2020. And it goes through lots of the different components: seeding rates, row spacing, fertility, weed management. So this is available online, either at our own website, which is www.postrock.ksu.edu, or you can go into our office and get that, or you can go online and get it yourselves through K-State.
You can go to KSRE bookstore. Okay. So in this case, it's KSRE bookstore, and go to the sections of crops, and you will find soybeans. As Sandra was saying, this is a kind of a summary of all the different topics that we discuss on our soybean schools. It will go from production all the way to insects, weeds, disease, economics, machinery. So we're trying to provide in a very few pages a summary of all the main topics for this 2020.
Okay, another book then is strictly on the Soybean Production Handbook. So this isn't updated every year. So this will maybe have some more in-depth information. This is updated every year and has some current information from year to year. So both of these are available on the bookstore or on our office as well. So we'd like to thank you for joining us today. My name is Sandra Wick, the crop production agent with the Post-Rock Extension District, and Dr. Ignacio Ciampitti. So if you want more information, contact any of our offices in Beloit, Lincoln, Mankato, Osborne, or Smith Center. And like us on Facebook. Go to our webpage and take a look at some of the other videos that we have. If you have any questions, feel free to contact us. So we'll talk to you later.